Good morning, students. Today I have discussed the topic heuristic methods. One of the important concept in heuristic methods in bioinformatics, because we are applied to some computational biology methods. So that's one of the important method for heuristic methods. Okay, that heuristic methods, it consists of two classifications, one for FASTA, another one for BLAST. Okay, first we are discuss for BLAST. BLAST means basic local alignment search tool. Okay, then another one important method for FASTA. Okay, so aim of the session to understand the heuristic method in bioinformatics. Then objective for that session, FASTA and BLAST. So finally you can get the outcome. What are the different heuristic methods in bioinformatics, then how to apply, then how to analyze the biological data. Okay, so these are the things for today we have discussed. So first of all, what are the heuristic methods? What are the heuristic methods? Okay, so already I told two important concepts, one for FASTA, another one for BLAST. Okay, that heuristic method is any approach to problem solving. Okay, to approach is any approach to problem solving, learning or discovery that employs a practical method, not guaranteed to optimal or perfect. Okay, so heuristic method is one of the important technique for bioinformatics, is any approach to problem solving, learning or discovery that employs a practical method, not guaranteed to be optimal or perfect, but sufficient for immediate goals. Okay, do you understand? So that's called for heuristic method. So what do you mean for FASTA? Fast sequence searching algorithm for comparing a query sequence against a database. Okay, so against a database means your original sequences. Okay, so FASTA for fast searching algorithm for comparing a query sequence against a database. So coming to the another method for BLAST, basic alignment search technique. That one for compare with FASTA is that algorithm for search speed, then easiest technique and then statistical rigor. So this is the small introduction for FASTA and BLAST. So what is the FASTA algorithm? Find the runs of identical words. What do you mean for identical words? That identical words means similarity of the region of the sequences. Similarity region of the sequences. Okay, so to identify the region shared by two sequences, or like two sequences means DNA sequence or protein sequence. DNA sequence for ACGT, then that one for first sequence, then CGTA, that one for second sequence. How to identify the similarity position that sequences? Here identify regions shared by the two sequences such that have the highest similarity of the or identical of the sequences, or two consecutive identities, that mean for k tuple equal to 2. Then another step for rescoring using the PAM matrices, percentage accepted matrix. In that method, longest diagonals are scored again using the PAM 250 matrix. The best scores are saved as the init method scores. Okay, so do you understand? That second concept for rescoring using PAM matrix, percentage accept matrix. In this method, it used to longest diagonals are scored again using the PAM 250 matrix. The best score are saved as the init scores. So this is the FASTA algorithm. Here this is the sequence A. Sequence A means for sequence 1, this is sequence B. Find out the similarity region. This is the diagonal region. Okay, here find the runs of identical words. Okay, this is first concept. This is second concept for rescore using PAM matrix. Keep top scoring segments. Okay, so first to find the runs of identical words, first concept. Then we have threshold for k top equal to 2. Okay, this is the rescore using the PAM matrices. Keep top scoring segments. This is for method for init 1. Okay, so first of all we have discussed the FASTA algorithm. What is the FASTA algorithm? What are the working principles of FASTA algorithm? How to work in that biological data set in the FASTA algorithm. So first join the segments using gaps and eliminate other segments. To find the long diagonals that are neighbor joined, the score for this joined region is init n. The score may be lower due to a penalty for a gap. Here do you have considered the gap for penalty value. Okay. Now already I have told the sequence alignment, pairwise sequence alignment, what is the gap, what is the similarity region, what is the insertion value, already I have discussed. So that concept you should incorporate in that FASTA algorithm. Use the dynamic programming, create a optimal alignment to construct an optimal alignment of the query sequences and the library sequence. You have using the Smith-Waterman algorithm. Smith-Waterman algorithm for global alignment for dynamic programming. This score is the reported as the optimized score. Okay, this is the FASTA algorithm working principle. Here FASTA alignments, already I told this is the FASTA alignment for join the segments using gap, eliminate the other segments. Then second one for use dynamic program, create an optimal alignment. Okay. Then what are the different versions of FASTA? So FASTA compare a query protein sequences to a protein sequence library to find similar sequences. FASTA also compare a DNA sequence to a DNA sequence library. So T-FASTA, translate FASTA, it compares the query protein sequence to a DNA sequence library. After translating the DNA sequence library in all 6 reading frames, then next version for FASTA X and FASTA Y, it translates a query DNA sequence on all 3 reading forward frames and compare all 3 frames to a protein sequences. Then last types T-FASTA X and T-FASTA Y. Then translate FASTA X and translate FASTA Y. It compare a query protein sequence to a DNA sequence database, translating each DNA sequence in all 6 possible reading frames. So coming to the next important technique in heuristic method, BLAST. Already told, BLAST for basic local alignment search tool. Okay, so here this is one of the heuristic method for local alignment. So FASTA for global alignment, BLAST method for local alignment. It designed to specifically for database searches. It based on the same assumption on as FASTA that good alignments contain short length of exact matches. So last FASTA is the long sequences. You can find the long sequence of exact matches. That BLAST for short sequences length of exact matches. So what are the input to the applied to the BLAST? So first input for you have given the query sequence, either DNA or RNA or protein. Okay, then you can another input for scoring scheme. That scoring scheme is nothing but gap penalty substitution matrix for proteins. So identity or mismatch scores of DNA or RNA. Okay, then threshold value W equal to 3 or W equal to 11 for DNA or RNA. So final outcome, you can get the outcome for statistically significant matches in DNA or RNA or protein sequences. So this is the algorithm for BLAST. So what are the steps in that algorithm? So 3 steps for. So for first step, find the query processing, query pre-processing. Second one, for scan the database, entire database you can scan for hits. Then third step, go for extension of hits. So this is the primary steps in the BLAST algorithm. Okay, first step for query processing, second one for scan the data for basis for hits, and then third one for extension of hits. Okay. So how to working that BLAST algorithm? So first for query pre-processing, you can create a neighbor word for each query that word. Here this is the maximum threshold. So L for length of the sequence minus W for you can W equal to 3 or 2. That's for we have given the threshold plus 1. This is the local identical word. This is the local identical word. This is the query word. Here seen, this is the P word. Okay, this is the length of the sequence. Here list of words of length W scoring more than T within the P word. This is the neighbor words. Okay, and this is another example for a list of words length of protein sequences. This is the protein sequences, query sequences for protein sequences. So word 1 for PQG, first 3 words. Then next one for next neighbor words QGE. Next consecutive keywords GEF. Then next consecutive keywords for EFG. Okay, this is the query processing. Final step, compile the short hit scoring word list from the query. So length of the query word is equal to 3. You can find that this is the protein sequence. You have find out the how many words in PQG in that target database. Here neighbor words. These are the neighbor words. Okay, total for threshold 13. Okay, then coming to the scan the database hits, for each word list identify all exact matches with the database's sequences. This is, look at, see, this is query word, this is neighbor word list, this is the sequence databases in the target sequences, sequence 1, sequence 2. This is the extent of the hits. Okay, so every hit that has been the generator now extend in both direction without gaps. Okay, so remember that this is the without gaps. To determine whether the each hit may be part of a longer segment with high score penalty value. Okay, this is the high scoring segment pair. So how to calculate the high scoring value in that heuristic method? If the extent segment pair has score better than equal to S segment, S for segment, it's a called a high scoring segment pair value. Then MSP for maximal segment pair. You can comparison for every sequences in the databases. You have find out the best scoring high scoring segment pair is called the maximum segment pair. This is the procedure for high scoring pair calculation value. Okay, this is the maximal segment pair for each word match extend alignment in both direction to find alignments that score greater than score threshold S. Okay, this is the Blast types. So sometimes they are asking for different type of blast types, comparison between blast types. So nucleotide blast, protein blast, blast X, T blast N, T blast X. So what do you mean for nucleotide blast? It is such a nucleotide database using the nucleotide query. Protein blast for protein database using a protein query only. Then blast X for protein database using translated to nucleotide. Then T blast N translated nucleotide databases using protein query sequences. T blast X for translated nucleotide databases using translated nucleotide query. Okay, these are the specialized for blast. So such a trace achieves then conserved domain your sequences, find the sequence with a similar conserved domain architecture, then single nucleotide polymorphism, then align two or more sequences using blast, protein or nucleotide targets, pubchem, chemical bioassays, and then multiple sequence alignment, global sequence alignment tool. So these are the specialized blast tool. Okay, so then extension for heuristic method for progressive method. In that method for used to approach multiple sequence alignment use a heuristic search known as the progressive alignment. So most of all researcher using that FASTA and BLAST. Okay, this is the extension version for heuristic methods. Progressive alignment builds up a final multiple sequence alignment by combining pairwise alignment beginning with the most similar pair and progressing to the most distantly related. Okay. Okay. So this is the heuristic method. Then first in that session, first what is the heuristic method, then what are the types of heuristic methods, then how to apply in the biological data sets, then what are the extension for progressive heuristic methods. Okay, so do you understand? Then we go for pairwise sequence alignment, that section next session. Thank you students.